هناك كلمة مسجلة عبر الفيديو للسيد ستيفان رئيس لجنة الإحصاء في هيئة الأمم المتحدة، سجلها خصيصا للمشاركة في هذا المؤتمر، لنتابعها سويا.
Dear colleagues, friends and festival participants, it's a great pleasure for me to join you virtually today to kick off the annual celebration of the Data Matters Festival. I congratulate my colleagues in the Palestinian Central Bureau of Statistics for this innovative idea and initiative, a Data Matters Festival, to celebrate the important role of data in improving lives, to bring together communities who care about good data. Statistics and data are more important than ever before. We need robust statistics and data to make informed, evidence-based decisions to improve the lives of people around the world. Without statistics and data, we are flying blind towards our destination of the Sustainable Development Goals. An ambitious response is needed to unleash the full power of the social and economic transformation to achieve the Sustainable Development Goals, and data are at the core of this. The Palestinian Central Bureau of Statistics has been leading the way, not only in the region, but on a global scale. PCBS is actively engaged in important international strategic discussions such as the United Nations Statistical Commission's high-level group for partnership, coordination and capacity building. PCBS is working with my office, the United Nations Statistics Division, on cutting-edge projects such as the Federated System for the Sustainable Development Goals, creating visually enhanced and easily accessible databases for SDG monitoring. The PCBS is an excellent example how a strong national statistical office can bring together and validate the best data available in a country. In order to do so, we have to be modern and bold and integrate new data sources such as big data and geospatial data, and use modern information technology. This is why it is so important to have occasions like this one, where statisticians, data scientists, private sector representatives, advocates, and data users can meet and start working together. In November 2017, I had the honor of being a guest of PCBS here in Ramallah. I was lucky enough to discover a beautiful land, rich in culture, but also rich in challenges given the conflict environment. But especially in difficult environments, solid data are critically important to take decisions that will affect people's lives immediately. This is why this festival is so important. I wish you good discussions, much success, and most of all, an enjoyable celebration of good data. Thank you.
أخرى، ونحاول كمان شوي نقترب أكثر من المنصة عشان نستطيع المشاركة والاندماج في جلسة النقاش الأولى.
الجهاز المركزي للإحصاء يوفر اليوم فرصة جدا ثمينة لكل المتواجدين معنا اليوم للتسجيل لدورات في علم البيانات يتم من خلالها التسجيل إما ورقيا في قسم الاستقبال أو إلكترونيا عبر موقع المهرجان المتوفر معاكم في الورق المخصص للمهرجان. فنتمنى أنكم تشاركوا في هذه الدورات لأنه هي فرصة ثمينة لحتى تحققوا نجاحات إن شاء الله في المستقبل من خلال علم البيانات بإذن الله.
التسجيل الإلكتروني عبر موقع داتا ماترز أو داتا ساينس للمعني في هذه الدورات التدريبية. مشاهدينا الحضور الكريم، في هذه الجلسة نستعرض تطبيقات من الواقع حول علم البيانات، ونرحب بمدير الجلسة دكتور يوري ريتشن، مدير شعبة الإحصاء في لجنة الأمم المتحدة الاقتصادية والاجتماعية لغرب آسيا الأسفل.
التطبيقات والأمثلة الواقعية تتنوع بين مجالات التنمية في السياق المحلي إلى الذكاء الصناعي لنحصل على نتائج صحيحة في حال سلكنا الطريق الصحيح. إليك دكتور يوراي ريتشان فلتباشر بالجلسة. شكرا لك.
Thank you very much. And before I embark on the session, I would like to thank the organizers, the Palestinian Central Bureau of Statistics, the Arab American University, and everybody who organized this festival for inviting me here. I'm always pleased and honored when I come to Palestine. And I remember a message which I got when I accepted this invitation. Welcome to your second home. And I really feel here being among very nice and talented people. Nice and talented people who through the hardship prove their ability to build their country, to maintain their culture, their values, and strive for a better future, which hopefully one day comes. And with saying this, I would like now to turn to the session which is about applications. But rather than about applications, I would say about what can data science bring to the society. We don't speak about applications for the smartphone. We don't speak about software. We speak about examples of data science bringing value back to the society. Because all data, whether collected through surveys or censuses or big data or remote sensing or mobile phones, social networks, etc., they originally come from the citizens, and they should return back to citizens for better information of the society. During the last several years, there is a tremendous impact that science and machine learning have on. There is obviously application in fraud and risk detection, but also in healthcare, in internet research, targeted advertising, website recommendations, advanced image recognition, speech recognition, we saw it on the video, planning of your travel, of your everyday life, and basically somehow augmented reality. When we live in the reality, but we have more information than ever before. Our speakers will deliver unique tasks on the real life use of data science in their work, and simply to put highlights on the importance of data science. So the first presentation on data matters, applications, comes from Dr. Faisal Avartan, who is a highly experienced expert in designing and implementing market research, socio-economic studies, monitoring and evaluation projects. And over the course of his career, he led various market research, informatics, and policy analysis studies, supporting international organizations that carried projects in Palestine. Dr. Faisal, you have the floor.
يعطيكم العافية. أول شيء بحب أشكر الجهاز المركزي للإحصاء أو ستاف بإدارة الإحصاء بالجهاز المركزي للإحصاء على الشغل الحثيث اللي عملوه لتحضير لليوم هذا، وعلى راسهم الدكتور على العوض. جريت ورك ما شاء الله عنكم يعني. بحب اشكر صديقي الدكتور وليد بيب اللي كمان كان من الانيشيترز للديتا ساينس دي، واللي كمان كان من الانيشيترز لتاسيس برنامج الديتا ساينس بروجرام ماستر بروجرام في الجامعه الامريكيه حاليا. اليوم انا حاب اشارككم بواحده من الاكسبيرينسز تبعوني في مجال الابلكيشن للديتا ساينس. انا بشتغل على كثير مشاريع في مجال الديتا ساينس. جزء من المشاريع اللي بشتغل عليها ومخطط اشتغل عليها لطلاب الماستر بالديتا ساينس راح يكون شيء بالهيلث كير، how to utilize clinical records or health records for helping physicians of making decisions. وكمان we're going to be working on something else اللي هو العلاقة بالcourt system، العلاقة بالcourt records of how to help judges and lawyers make use of that using predictive analytics models and artificial intelligence algorithms. اليوم بدي احكي عن اكزامبل اشتغلت عليه من خلال مشروع انعمل بالاردن بالتعاون مع مؤسسه امريكيه اسمها FHI 360. المشروع هذا كان regional project for supporting issues for micro and small enterprises in Jordan, also at the regional level. The idea here was basically trying to come up with a system to support micro and small enterprises for economic development and for job creation. As you know, micro and small enterprises in Jordan, Palestine, and Lebanon, they basically comprise almost 99% of economic establishments. So the idea that we thought about is how can we study what we call growth determinants of micro and small enterprises. And the idea also was trying to come up with job creation mechanisms, how you can create more jobs in the Jordanian society, and of course later on in the Palestinian society, and then in the Lebanese society at the regional level. So what we did is we decided to target micro and small enterprises. So the example I'm going to be talking about is from Jordan. Through our work, what we did is we did look at the micro and small enterprises in Jordan. If you look at them, you notice that 99% of the firms in Jordan are considered to be MSCs. Micro and small enterprises contribute to 50% of the GDP and contribute 45% of the exports. MSCs also employ 71% of the workforce across all sectors. So this gives them a special importance to be studied and to be catered for by all international programs for supporting economic development. So to study the micro and small enterprises and what we call growth determinants for micro and small enterprises, what we did is we designed a survey that used a sample of 4,700 MSCs. Through this survey, we were interested in studying the growth of the MSCs. Okay, so we defined what we call our study variable. Is we looked at various variables, but we looked in particular on whether the micro and small enterprise hired any person through the past year, or the number of people they hired through the past year. So this was our what we call growth factor. Okay, or the variable that we were interested in studying, and we wanted to study what factors influence the growth of MNCs. Okay, the other background background variables that we looked at through our data collection mechanism was we looked at formality of the micro and small enterprise. We looked at education, we looked at sector, we looked at use of technology, age of the firm, inter-firm cooperation, gender of the owner, and social networks. These were all background variables that we collected about the 4,500 micro and small enterprises. Okay? And the whole idea was, of course, to study which of these factors are considered to be important, which factors are less important. So what we did is, this survey had two applications. The first application was to inform policy, or to inform the project director who were planning to do some interventions in the Jordanian society to support micro and small enterprise development. Okay, and the other application is to really create what we call to build a predictive analytics model. Okay, I'll talk about this in a minute. So what we did is basically, other than informing the what we call the project director who was interested in learning more about MSCs in Jordan and therefore designing what we call program activities to support micro and small enterprises. We were working with microfinance organizations at that time as well, what we call also the Microfinance National Bank in Jordan. And the Microfinance National Bank in Jordan were interested in learning how they can lend micro and small enterprises. The idea of giving them loans is also part of what we call access to finance. And one of the most important impediments for economic development sometimes that micro and small enterprises don't have access to finance and the banks don't lend them money. So if you can come up with a scheme that can help the banks and help MSCs to bridge that gap of information between both of them, then you might help them to have more access to finance. Okay, so to do that, what I did is I designed what we call a multivariate logistic regression model. That's our what we call predictive model, through which we did an analysis of the data, and we came up with that model, and the results were as follows. The most important factor, because in our survey, by the way, we targeted formal and informal micro and small enterprises. Okay, the most important factor that showed as an influential factor for growth was what we call formality. So those who are registered were more likely to grow than informal micro and small enterprises. Now, this result by itself led to a policy change in Jordan, by the way. At that time, the project initiated a policy, let's say, dialogue with the government, and this led to the fact that the government allowed what we call home-based businesses to register from home. And this law passed in Jordan, and they allowed what we call home-based businesses to register and become formal. So this, of course, will help home-based businesses to access finance, because without being formal, your access to finance becomes a bit questionable. Okay. So we looked at if you look at the results of the model, it says that those who are formal are 3 times likely to grow than those that are informal. Those firms with a person who's educated are twice likely to grow than a firm that is owned by an uneducated person. Also, we looked at sectors. There was also a change in sector. There was also a significant contribution to the sector. The other factor was also use of technology. So micro and small enterprises who are using recent technologies like social media platforms, all this stuff, are twice likely to grow than those who are not using technology. Of course, by the way, to understand the full details of this model, you need to attend data analysis class with me, and I have a couple of students here in my data analysis class, Alex and another student here. So it's, I will present this in my final lecture, by the way, for you guys. At any rate. So now, after all these results that they informed policy, what we did is I basically did these results now were programmed, and I created a model that can predict the growth of an MSC based on some background variables that we collect about the micro and small enterprise. So, for the micronational bank in Jordan, now when a micro and small enterprise applies for a loan, they ask them 10 questions, and based on these 10 questions, they feed the answers that they get on these 10 questions, they feed them to the model, to the multivariate logistic regression model, and the model will tell them, this person give him a loan, this person won't give him a loan, this person give him with caution, and so on. So this model now is being programmed, and it's being integrated in the decision making that the microfinance institutions are using. And also, of course, I helped them create what we call a credit scoring model based on the data that they collect internally, because they have 90,000 loans with background variables on all the persons who applied for a loan. So we used what we call credit scoring from internal data, and we used what we call the growth scoring model that was used from primary data that was collected. And this is becoming now part of an artificial intelligence program that will get embedded within their decision-making process. And in the future, it becomes an online application. So anyone can apply online, and you will get your response online as well, because everything will be automated. Thank you for listening.
Thank you, Dr. Faisal. We will come to the next presentation. And before that, I would like to emphasize the things that we are learning. We are still looking for where is the right path. We may go to the dead end, go back and try to explore other possibilities, because there are very wide possibilities. We have all the components. We have mathematics, we have statistics, we have computer science, we have expertise in subject matter areas. So we need to find the right path. And that will be the next presentation. Data science, the right path, the right results. I would like to invite Dr. Amjad Abur-Milek, who is a senior data scientist and a biomedical and automation engineer who got his degrees from bachelor's to master's, to PhD, with experience in biological signal processing, machine learning, estimation theory, system identification, and advanced control algorithms. Dr. Abur-Milek, you have the floor.
So we have some technical thing here. السلام عليكم، مساء الخير للجميع. كنت بتمنى نعمل محاضرة بالعربي، بس للأسف إشي ما استعملتوش بالعربي كثير، لأن ما تعلمتوش بالعربي وبالشغل ما استعملتوش بالعربي، فممكن معظم الفيديو راح تكون بالإنجليزي. So now I'm switch to English. I was thinking to do everything in Arabic, but unfortunately I didn't use Arabic in my work and in my education, so it's more difficult for me to use it in Arabic now, so I'm doing it in English. Till we solve our technical issues, I'll start with my first slide, which should appear now. My background, as mentioned, I did my first degree and my second degree in contour theory and biomedical engineering. My PhD was in contour theory, and by the end of my PhD, I started to hear about this machine learning, that science thing, so I wanted to be part of this kind of things. When I came back to the country, during my postdoc research, I started doing machine learning and data science in the field of neuroscience, where I studied the interaction between machines and brains. Afterward, I went to Microsoft Research and I joined the recommendation system. And at Microsoft, I joined the recommendation system team where all the Xbox, Microsoft Store, and all these kind of recommendation you get in Microsoft things, it was a product of this group. Then I left Microsoft, and now I'm leading a group of 25 data scientists working on consulting on different projects, on different verticals, different companies from the size of Microsoft itself to start a small startup of 2 or 3 persons. So today, the main idea was to do a little bit recap of what is the real data science from someone who's doing it day to day, and to say something about the data science journey, the steps that we are following every time we get a new project. And once I get a new candidate, someone is interviewing at my company and I want to hire her, there are some set of skills that I'm looking for. And at the end, I will give, if I have time, some kind of free life project that we work on. So, in a few words, actually this is a very new field, so nobody has a very well-defined definition of this field. But I would say it's kind of extracting information from the data itself to make better decisions. So make some kind of actionable knowledge, something that you can use data, transform it in something that can help you doing better decisions or better understanding at least. So what is data scientist? Data scientist is someone who's doing this work, who's doing the data science, but he has a set, or she has. Actually, one of my best data scientist is she, not he, so I would also encourage all the girls here to apply for kind of these things at the beginning to learn these things. So the data scientist is someone who's equipped with a set of skills in machine learning, statistics, math, business knowledge, so you have to have intuition about some kind of the problem that you are touching in order to bring the machine learning or the science project end to end. At the end, your product is kind of a working algorithm, a working pipeline that your client is willing to have, and he's paying you for this. So data science is a very huge thing, and we can say that science and think that it could be applied in a single field. You can see here that it can be anything. It can be predicting if the mail that you are receiving is a mail spam or not. It can be predicting the price of something. It can be recommendation things that you get in Amazon or Facebook. It can be recognizing what is in an image. It can be saying if a text you are reading is kind of positive or negative or has some kind of bad word, and so on. So you have a lot of applications where that science and machine learning can be applied. So in our day-to-day life, everybody, maybe many times a day, you are using Google search. And behind this Google search is a huge machine learning and data science pipeline that is bringing billions and billions of dollars to Google every year. We have all in your smartphones, you have Siri, you have Google Assistants, you have Alexa of Amazon, all of these voice assistant things. Cortana of Microsoft, they are recording your data, learning from your data, and using your data in an anonymized, private way to be helpful for you and for other people. All what we see in the tagging of Facebook images or something like this, the tagging of the image, recognizing what is in the image, it's a car, it's a person, it's kind of things. And they are using this kind of things in order to learn more and get more out of these things. For example, if you are one who is posting a lot of flowers photos in Facebook, Facebook will start detecting the image of flowers in your Facebook and recommend you advertisement of company related to flowers and agriculture. So they learn from all your images or what you are writing and posting, so be careful. The translation thing you are getting in Microsoft, this is still one of the state-of-the-art algorithms working here. It's a very complex thing, how to pass everything in a good way from one language to the other, sometimes even in languages that Google Translate never seen before. The recommendation you get in Amazon, in Xbox, for example, you buy your kid some kind of game, the next time you come, you see a lot of things related to what you bought not the same thing, something that is related, so they know what is your taste, what they are looking for, and they are trying to drag you or attract you more in order to buy more. And eventually, this is the fancy thing we heard about from this morning, the self-driving cars. You can see that we already have this kind of Tesla, BM, Mercedes cars that are driving self-driving in some cities in the world. They are based on machine learning, image recognition, data science, and processing millions of images per second or something like this. So from these things, you can see that it's working, but unfortunately, from recent statistics, we can see that most of the machine learning data science projects in the world failed, and they mostly failed in early stages because sometimes the lack of vision or the lack of very good plan. At our group, luckily enough, we are getting a success rate this year it was 90%, so hopefully we are doing something right, and this is what I'm trying to share today. So the data science journey is starting by having the first or few meetings with the executive level of the company, the manager, the C-levels, those who can make a decision, those who can make a change or decide on a change. We can listen what are their main points, what is painful for them in their applications, and what they think what could be use cases that we can tackle their problems. They can have a lot of problems. We start with a few of them. And we say, okay, let's plan for the first project. The planning is what is the time scale? Should we work on 3 months project, 3 years project? It's a long-term collaboration, short-term collaboration. Then we start getting what is the kind of data set you have. It's a kind of structured data, unstructured data, images, text. If you are going to store the data at your side, at my side, in the cloud, so all of this, the data privacy, the anonymization of the data, we don't work with data that is not anonymized. We want to protect the privacy of people. Then once we get the data or the first batch of the data, because some data is very huge and I'm not working with the complete data at once, so I get the first batch of the data or the first data set. I start forming the data science team, which is out of the 25 data scientists that I have, I should ask the question, which one is the most suitable one to sit on this project? If it's someone that I know that's who solved a similar project in the past, I will most likely think to put him in order to get some kind of quick results, but it's not something that I'm doing usually. I want to involve other data scientists also in the process. So maybe I will bring a fresh one, but it will be with the supervision of someone who's more senior, someone who has more experience. Then we start our real data science work, which is the methodological tools. Starting getting the data, I start doing what we call the explorative data analysis, or exploring the data, see what kind of data I have, what kind of missing values I have, if there is some kind of correlation between the target variables, if there is what is the independent variable, is it a continuous thing that I'm trying to predict, or a discrete thing, what we call regression and classification. Maybe I'll tackle on this later on. Then I will go for what we call the machine learning or the AI, the core of this kind of thing, the model that I'm going to use. At the beginning, I'm trying to get something that is simple and working, what we call a benchmark or a baseline. And if the client already has some kind of something working at their system, I would say, bring it to me, I'll compare my results to your baseline. So having a baseline is something that is causing the failure of a lot of projects. I'm getting 95 accuracy, but maybe by chance you can get much more than this if your data is imbalanced. So you should have a baseline to compare your results to. And once you have your proof of concept or your model working, the final objective of your client is not to have a working model. He wants to deploy it in a production, to have it working somewhere, to provide recommendation for Amazon, for Facebook, or for your local sales, for banking, for telecommunication, and so on. So this is a very painful point here, and also a lot of project fails there, because maybe I developed a very fancy model, but it's heavy, it's slow, and the requirement of the client is to be a fast model, a model that is giving response in a few milliseconds. So my fancy model will not work here. I'll go back and I will replace it with a simple one that is working in a better way. or I will like trade off accuracy for speed and something like this. And for this one, we have three software engineers or DevOps engineers that are working in our team. This is their main point, to optimize the whole pipeline, and they are focusing on this point 7. And once you have a model that is working, you want something to keep monitoring it. I don't want it to work today and fail tomorrow, because you want something that is giving you money or bringing you money and benefit and good insights all the time. So you have to be monitoring your pipeline all the time. So here we have a product for us that we are developing. I'm not giving some kind of advertisement, but it's based on heavy statistics, heavy mathematical modeling here, because I'm trying to monitor all the points from the data set itself. If the performance of the scientist is consistent, if I switch the scientists between the phases of the project, maybe their performance is not equal, so I have to detect this also. Machine learning algorithm can be problematic, so I'm trying to monitor its input and its output. So I can put some kind of sensors and probes between number 4 till number 7 everywhere. Okay, so we finished our generic pipeline. So who's doing it is a scientist. That science, as we said, it has like a multidisciplinary thing, but for me, someone who's coming to interview should have some kind of level in all of these things. I don't want him to be perfect in all of them, some kind of, depending on the position and the position and the background that I'm expecting from his CV. I expect him, for example, to have some kind of level of mathematics, because at the end, machine learning is kind of linear algebra, optimization algorithms. You have metrics that you have to understand, what is the error, what is the mean standard deviation on all of these things. Statistics also, because we are doing feature engineering, we are doing features, we are doing correlations. I want him at least to know what is, for example, what is correlation, what is ANOVA test, what is variance, all kind of things. I'm not asking for very advanced mathematics for everyone, but someone who's coming for advanced level, whether a senior or principal scientist, he should know at least the advanced things of 2 of these points. Programming skills is some kind of a language you are learning. If you know, for example, Java, Python, R, I don't have a problem, because I know that you will do some kind of knowledge transfer or you transfer learning to another language, so this is not critical, but I want you at least to know some kind of programming language. Machine learning, which is the core for me, for that science, which is making a difference between data science, business analytics, business intelligence, and all of these things, because all other fields, they don't involve this machine learning thing. So machine learning is the core that scientists from my point of view. Data visualization, I want him to know what is the kind of visualization that is suitable for different kind of data, because if I'm plotting everything in a pie chart or a line plot or histograms, it's kind of not suitable for all kind of data. Data language, which is kind of how to manipulate data, how to produce new data, new features from old features, how to combine data sources, how to clean, how to remove outliers, how to detect outliers, and all of these kind of things. These are like the technical skills, but I also want him to have some kind of personal skills, like critical thinking. I want somebody who knows, after the meeting with the client, someone who can identify which points are painful, which points are important, which points are less important, so I can leave them to a later phase. I want somebody to know how to go research new problems, open articles, open new books, open videos, and bring me the solution. I don't want to tell them the solution every time we have a problem. And also, I want somebody, this is something lacking from most of the fresh graduates, they have most of the technical skills, but business insight or business, how to know that your output or the technical output is not always what the company is looking for. For example, you can give me a model that is very accurate in performance, but it's not the model that is optimizing my KPI or the interest of the company. So you should know that I should switch for another model that is achieving what the business is requiring. So the business insight, and this is something you can get only by facing the real projects. So if you go to the field, working in companies, in the first project, in the second project, here you will get the skills. And at the end, because you are communicating with clients, because you are communicating with people, with teams, because that science is a team game. You are not working alone on the project. You know how you should know how to communicate with your colleagues, and you are telling a story with your data. And you should know how to communicate your results to the client and to the world. And once we have a business meeting, you should know how to communicate our power to others, what value we can bring to others. If we are the strongest and we can't communicate, this is a problem. So communication skills is very important. And as you can see from this diagram, that depending on your position, your skill set required is different. So it's not one size fits all. So as I said, machine learning is the kind of the core of that science pipeline. So what is machine learning? It's kind of like giving the computers or the ability to learn. We feed it with previous data and we say, okay, learn the rules that can generalize for new data, for example. And there's a huge difference between machine learning and what we call software programming, because people say, if you are strong in software programming, you will be a good machine learning engineer or a scientist. This is not completely correct, because there is a huge difference in the concept. For example, in traditional programming, you have your data and you design the rules and you feed the computer with the data and it will bring you the final output. In machine learning, it's the opposite. You have the data, maybe only the input or the input and the output, as we will see later, and you feed it to the computer, and from this example, you tell the computer, learn the rules. Because in the future, I'm going to use these rules to predict the next coming input data. Okay, as you see, machine learning is a huge field. It encapsulates three main fields, as we say: supervised learning, where you have the input and the output; unsupervised learning, where you don't have the output, but you know only the input, so you have to cluster or to group your data based on no knowledge on the output. And we have the fancy reinforcement learning, the thing that you see in all the games. This one I'm not going to tackle today, because it's really complex and it's still not working in real life. So supervised versus unsupervised. In supervised, as we said, I have the label. I know that this is a photo of a cat, cat, dog, and so on. I provide it to a supervised model, and once he learns the rule, I provide with a new image he didn't see before, and he knows that if it's a cat or a dog, so he should give me a cat if it's a good model. It will be confused if it's a bad model. In unsupervised, I don't provide, if you say I don't provide the label here, I only provide the images, and the computer should learn some kind of common things or common features that separate these things into clusters, into groups. So this is what we call unsupervised learning. I'm teaching it without giving it the real label. The two concepts that you will learn a lot in your starting your machine learning or design journey is regression or classification. Regression, I think a lot of people here know what is it. So regression, when you try to predict something that is continuous, and predicting what will be the temperature tomorrow, it's like 80, 85 to 82, 82.5. It's a continuous thing. While in classification, it's kind of very discrete thing. You have two options, it's hot or cold, or maybe something in between. So this is the regression, you predict something, your output variable, the thing that you try to predict is kind of continuous. In classification, it's kind of discrete. Okay, so after this very quick crash course of machine learning, I wanted to talk about some kind of the project that we developed. We work on different verticals, so we have projects. We have a strategic partnership with MasterCard, EY, and Oracle. So we have continuously have projects coming from these three companies. We have also a project in telecommunications. We have with Visa. We have in Tabula, which is advertisement. We have a new credit, which is a gold mining project. They already have a lot of money, and they want to increase this money using machine learning and data science. So we have a project with these people. Medaware, I'm going to tackle this one. SolarEdge and StoreDot is kind of new energy and renewable energy companies. They are also trying to push machine learning and data science. FDNA and Imagine are like medical companies. They want to use machine learning and data science for healthcare. So I will just go for Medaware. Medaware is kind of trying to predict the error in medical prescription. Given your medical history, I try, once you are in the hospital, for example, now, or in the clinic, if the physician is giving you a drug, I want to know if it's a correct one or incorrect one. Medical errors is the third cause of death in the US, and this work is already working in kind of hospital. CDR is kind of a telecommunication based on your transactions or your phone calls. I can know if you are a good customer or a bad customer, a customer that is going to pay his bill or not, and I can also identify some kind of, if there is good customer that belong to other operator, to other company, I can identify them using machine learning, and I can go to them and like doing some advertising for myself. Okay, Tabula is kind of predicting if your content, for example, if Tabula is, you send your advertising over internet, and they should publish it on some site. So we are doing their image recognition and text classification to know if your advertisement is kind of suitable or not. It's passing through our pipeline. If the advertisement contains some rejected content, we don't pass it, so we save them some money and some time in order not to go on this manual by humans. And this is for HR thing. Given the features and the performance of some kind of employee, you can predict if he's going to leave or not. And once on this results, you can do some mitigation plans, going to him, solving the problem that's causing him to think about this, and so on. And this is, I will not go over this one. This is a cybersecurity thing. So in a few words, you can apply that science almost everywhere. It's important to have a clear vision and a clear pipeline, and like a data science team that has a different set of skills. Not all data scientists are required to do the same job every time, so you will know how to develop your vision and store your data, for example, in a very good way. So I think we are done with this, and thank you very much.
Thank you, Dr. Abu Milek. And sorry for a little bit rushing you, but it's very rich information. We can speak about it for much longer time. And therefore, I would like to ask the organizers from the PCD and the presenters whether they would agree to have these presentations published on the website of this festival, because they are extremely good educational material, and we would like to come back to it again. There is a lot of information, and we do not have even the shortage of time moments to absorb it all.
So first of all, I thought to share it on my LinkedIn and on my Twitter, for example, but I don't have any problem to also share it with the organizers and publish it somewhere more public, so I have no problem with this one.
Thank you very much. And before we come to the next presentation, I somehow recall, after a certain age, people start to be too nostalgic, but that's not my point. I remember when I was 25, inverting a matrix 6 by 6, which I needed for the regression model, was a great challenge. And a lot of manual work and fiddling this huge computer. Today, we run these models, even we do not know where it is hidden in our tiny laptops and computers. So the computing power, the storage of data, the possibility of absorbing all this data has tremendously increased over the time. And therefore, because the storage was expensive, do you remember when 1 megabyte USB stick was something what your spouse could be complaining if you bought it from your own family money? Now it costs nothing, this storage, and much bigger than just 1 megabyte. So we have these amounts of data, and we can analyze them, and we have powerful algorithms. The machine learn by themselves. I am a frequent user of Google because I work in the Arab region. I live in the Arab region, or with the Arab region, and I don't speak Arabic. Therefore, I need a translation. The translations which I got in 2009 when I came to the region, and which I get today in 2019 are not comparable in their quality. And it means the machines learn. They know what they do. So we have a huge amount of data. We have the learning of those computers, And we leave the humans the more sophisticated tasks. And this is what Dr. Eyad Elian will be talking about big data, big ideas from the artificial intelligence perspective. Dr. Elian is a reader at the School of Computing at the Robert Gordon University. Dr. Elian also served as research assistant at the University of Bradford, from where he obtained his PhD in machine vision 2008. Current research activities are focused on data analytics and advanced machine learning. His specialties include machine learning, image processing and analysis, and data analytics. Dr. Elian, the floor is yours.
سجين سادة أزمن. في حدا هان كان سجن في سجن النقب بالتسعينات والانتفاضة الأولى. This is just for statistical information. One, is there any more? والله تغيرت البلاد يا جماعة. 2, 3, 4. كمان ارفعوا ايدكم الحكومة طلعت. Don't worry. طب قبل ما ابدا العفو بقول to my students, you should know your audience. And to be honest with you, أنا فلسطيني وابن البلد, and I want to speak Arabic as much as I can. يعني لأني أنا very, very impressed by what the PCB did, really, and the staff and the organization and the vision. And thank you very much for the invitation. Honestly, I wish if I could help in any way to shape up data science, AI, big data in Palestine, because I don't think we have anything else but the brains, you know. You've got to be tough and work hard. And my question next, before I start, how many students we have here? Please answer. Students? That's not very encouraging, guys. I all respect. How many of you want to become a data scientist? I am very proud of you. How many of those who are not students want to become a data scientist? Okay, I have two pieces of news for you. There is a good news and there is a bad news. The good news, you will get paid really highly. My PhD student graduated with a PhD thesis on reinforcement learning. It's a great topic. Don't worry, it's not complicated, you can learn it. He's working for Shell now. He's earning more than £100,000 a year. So it's possible, you know, and he did this in 3 years' time. So this is the good news. The bad news, I want you to read this, please. And just to give you a context, those two guys, oh, that's too far. They finished their PhD in machine learning at MIT, and they went for job interviews. Just say what they applied for data scientists. So basically the guy wants them to do everything. But what I really love about the second task is that this guy who went to the interview here, he was asked then by the CEO, he told them, I will give you a simple task that will take you a few hours. And this is data science in practical context. Go and please pay attention to all the red lines and find some data, publicly available data set, several hundred of gigabytes of size, make your own questions, in other words, articulate the problem, make the assumptions, code, fit the models, conclude, and report. This is, in essence, what you are supposed to be as a very confident, proud, highly paid data scientist. And you can do it, and it takes you 5 years, you know? And that's on me. If you don't get it by 5 years, so there's a lot of work there. It's not one master's degree, it's not one PhD, it's not one university, it's the whole society together. And I think we have to change the culture, and we have to work hard, and as much as we can. Now this slide, I added it based on some discussion today, and I will go back to my own presentation. I will skip quickly on the outline because, you know, I'm a boring academic, so I usually want to tell you some background, research challenges, and the data science in Palestine. This is really what matters for me. And then I will conclude with what we call the knowledge exchange. In background, just as my friend Abu Mela said, where is Sufyan Abu Harb? Sufyan told me, don't do any technical stuff. You will be shot if you do. Yeah. So this is the simplest possible thing I could come with about machine learning. Data science, big data, and AI, I can, with my limited artistic skills, say that it is transforming large volume of structured and unstructured data into knowledge, and knowledge that will lead to a lot of opportunities. This could be money, it could be saving time, it could be saving costs. I was chatting with Sahar today, I'm not sure where he is, from Bank of Palestine. You are doing some decision making. You know, we have our cognitive biases. There is evidence, and I'm a strong believer in that the machine learning algorithm is better than me and you and us and our collective experience. Because generally we judge things based on our own beliefs and experience. We are biased. We have even cognition illusion, not only cognition bias. I will skip quickly this because I think Abu Meir talked about it. The opportunity today is that you have large volumes of data. Again, I'll talk about Bank of Palestine. I apply for loan at the Bank of Palestine, and so many people. Some people will get the loans and pay their loans. Some people will get the loans and default. Some people will get rejection. The Bank of Palestine is doing his own stuff and his own experience. A model will give a better decision making than the current semi-automatic process. With all due respect to the Bank of Palestine, it's for any bank in the world. We need to take the human cognitive bias out of the story. I would highly recommend, especially for those who read and lead and manage big teams and want to change things, to read the book called Thinking Fast and Slow. How many people read this book? It's a good book. It was a very good book. I learned a lot. It shows you how easy you can make a mistake, you know, because sometimes even we follow our own intuitions. This is a very nice article when I was preparing to this talk at the Business Insider. We have 58 cognitive biases, you know. So check your biases. Think carefully before taking a decision. The guy on the top right left, who knows him? Oops. This is Sheldon from Big Bang Theory. He's a very nice guy. Watch it. Now, okay, why we are today talking about big data? Why everyone wants to do big data? Why everyone? I think it's simply because of the AI. By the way, AI and machine learning was there since 1947. I think the first perceptron was made on 57 by Rosenblatt. He published his paper. In the 80s, they published a book called The Death of Neural Network. In the 90s, people start talking about neural networks. I know, like Mike Faisal, you did your PhD in neural network. In the 2000s, we started to see changes. I think, and that's my own thought about it, I might be wrong, there's three main reasons. One is the data. It's exponential. It's not only the AI that is exponential, it's the data. This infographic is from 2014, so it's 5 years old. Notice 5 years old now is outdated. There is 1 billion Facebook users there, but now we have 2.5 billion Facebook users, you know. Then if you store the data on CDs and stack the CDs together, you will reach a stack that is 80,000 kilometers long. That's shocking. That's beyond any human ability to process or contextualize. What is even more worrying today, and I think the Prime Minister, and I really like his talk, I generally tend to disagree with all politicians, but he was really impressive. The Prime Minister mentioned, like, yeah, governments and big companies control the industry. I fully agree. AI is expected by 2030 to attract 16 trillion US dollar almost. Now this is not the surprise. The surprise is that China will take 7 trillion out of those, which means that China will outperform the US. US 3.7, Europe is 2.5 trillion, big Asian countries like Japan, India, and Malaysia, the rest. The Arab world is not mentioned in the story. I don't blame you guys, we are in the occupation. This is a big thing. China knows. I was in a conference in Budapest in July, and it's one of the top international conferences in neural networks. Half of the papers that were presented were from China. Half of the papers that were rejected from China. China is coming, guys, so start learning Chinese. This is my advice. Number two, the advances in machine learning and AI. And I just put one slide, and because I want to make Sufyan happy, where is Sufyan? I'm not going to talk about the peak. I think the turning point was after 2006, perhaps, where we started to see deep learning kicking off. Deep neural networks that are designed to think almost as you as a human being. Okay? I'm happy to explain and discuss and share any knowledge with any of you guys if you are interested. The third important factor to this high and of opportunities is the advances in computer power. I remember when I was an undergraduate, I used 15 floppy disks to install Windows. Now my team who works with me, we bought this machine. This is called NVIDIA DGX. I don't know, maybe Abu Bailey, you got to work with it. This is like this size. It cost $130,000. It's not a huge investment. I know Palestinians have money, the business people. This can process up to 1.3 billion images per day. You know, even looking at them, you cannot do it in your entire life. So these three things, if you put the data, the machine learning and the power of AI and the computer power, the sky is the limit. And that's what happened. Now the significant improvement that is going exponentially started soon after that. Without too much details, there is a competition called ImageNet. It's 1.2 million images available for the public to use for research. People are developing AI algorithms to see how much accurate the machine could learn these objects. So the machine will tell you if there's a cat or a car or an apple or a human being. Just watch this bar plot. In 2010, the error rate in the machine algorithm's results was almost 30%. In 2015, it went down to almost 5%. You know what is today? Today, deep learning is outperforming deep learning outperforming humans in recognizing objects and images. Tell me if this was like science fiction, even maybe 10 years ago. Deep face. I did my PhD in 2008. I obtained it from Radford University, and it was on 3D facial modeling for biometric face recognition. Just in 2014, Deepface released Facebook released Deepface. They achieved 97%. I felt my PhD is obsolete. I don't teach of my students any of what I did during my entire PhD. What all I learned in my PhD is put aside now. It's just the determination, the hard working, the coding, the results. But the technology is outdated. It's only 6 years. Or a PhD thesis that my mom is very proud of. It's gone. The most celebrated achievement, and again here a disagreement with Abu Mele, is what happened in 2016. And I think this is mind-boggling. In 2016, DeepMind developed an algorithm called AlphaGo. I don't think any of us here knows what the Go game is. This is a Chinese board game And actually, it's very complicated. And it was always the biggest challenge for the machine algorithm community. In 2015-16, DeepMind developed an algorithm that outperformed Lee Sodom. Now, why the whole world celebrated this, and I don't think it was much celebrated in the Middle East in general, despite the fact that in 1997, actually, PM won against Kasparov chess. What's the difference between the two? Maybe I'm too long, yeah? I need to... In 1997, guys, IBM created a supercomputer and fulfilled all the possible combination of the chessboard moves. So the computer used to calculate in a fraction of a second hundreds of thousands of moves and won. In 2016, you cannot do this because the possible combination on that board is more than the number of atoms on the planet. So here we have a machine learning algorithm that learns and generalizes like human beings. What about tomorrow? I will quickly skip this. Ray Kurzweil, read about this guy, and he believes that, as Sandy said, we are living in the exponential non-linear life. And he says that the technology is actually progressing exponentially and in a predictable manner. What does that mean? In 2015 and 2050 at most, pessimists say 2070, robots will be more superior than human beings. We might be exterminated, guys, so you take care of this. And read this. Challenges, I will quickly go through them. The first challenge is Donald Trump, obviously. It's not Trump. You know, I put him as a challenge because we have problems in Palestine with him. If he behaved, I will move into the opportunities section. Fake news and fake media is a big problem, and I think Sandy talked about it. You might appear in a video saying things that you never said and doing things you never did. It's a big challenging problem, and I can't claim that we are doing much progress, but at least we are trying. So one of my PhD students worked with me, and we discovered the shocking fact that there is hundreds of ways to fake a video that is not easy to capture. This is from our board. These two screenshots from a video, one of them is fake, one of them is authentic. You cannot tell by eye. I don't know if anybody can tell. The top one is the original. The top one is the fake. See, most people would say so. Because we did some work at the underlying level to learn the compression parameters. Again, I'll skip this, but please ask me. I'm happy to share the paper, and I have some of the code to share. We believe in open research community. Training example, Angela Bermeri mentioned like things like labels and stuff. We did it before. I was talking again to the Bank of Palestine. Data is biased, just like us. If your data is biased, we did some work here to actually generate the data from minimal number of data images. This is some of my PhD student work as well, where you generate such data over thousands of iterations, and then you can feed it into the data set and progress. We could re-engineer the data, restructure the data, you know, and again, I'm happy to share all the papers and the results with anyone interested here. I will skip the case engineering, but I want to say one thing about this, because I'm running out of time, and I'm sorry, you can stop me anytime, I won't complain. This is a project, and this is maybe useful to share with Palestine, that was developed, was funded by the government partly, by a company partly, and we were involved as a university in the development of the solution. This is a very complicated solution for a very complex problem. It doesn't resonate here because we don't have oil and gas. And it saved the guys hundreds of engineers' hours. In the oil and gas, the engineering hour rate is hugely high. Now, the interesting part of the story, the girl who developed this solution, she was one of my master's students. And when I recruited her to do the job as a research fellow, she has zero skills or knowledge in deep learning. She was trained in 3 months, and deliver the solution in 9 months. So yes, we can do it. And girls, my experience, girls are doing better in science and technology than boys. 5 of my team are girls, 3 are boys. I have had harder time with boys in general. Honestly. Now this is what I want to say about Palestine, because جميعنا بنحب فلسطين. Can I have another couple of minutes, sir? 2.5. Thank you. With no particular order, the private sector is very important. Banking. Guys, you have the problem, you have the data, and you have the domain expertise. Yeah? We need these 3 things. You have to come forward and open up with universities and say, so this is very important. The knowledge and technology, it's very interdisciplinary domain. The underlying knowledge, stats, probability, linear algebra, you need to keep these things in your mind. The tools and technology. If you are doing data science and you don't know R or Python or GitHub, at least, don't talk to me, yeah? Because you are not doing data science. You are doing statistical analysis. With all respect to stats, statistical analysis is not a data science. If you want to move further, do Keras TensorFlow. By the way, Kaggle, how many people heard of Kaggle here? Kaggle is a great source. There are people in the world called Kagglers. Google them. Google, Facebook, DeepMind are recruiting from Kaggle. You know, companies put their data sets. People participate in solving their problems online and sitting home and doing work and then get paid high jobs. Become a Kaggler, yeah? Think big. Think big, start small. Yeah, we know we are under occupation وعندنا حواجز والبلد تعبانة وحكومتين واحد هون واحد بينزل. It doesn't matter, you know? You can still think big and you can start small. By the way, DeepMind, guys, the AlphaGo, I told you the most celebrated AI achievement. DeepMind was founded in 2010 by 3 PhD students from Imperial College. You know what was the purpose of the company? They just want to write programs to play old games. In 2014, in 4 years, it was bought by Google for $500 million US. Yeah? Why not thinking big? You know, we have eyes and brains just like them and perhaps tougher life, which might make us more resilient. This is for مركز الإحصاء الفلسطيني because I really love the fact that they started this event, and I know it's the first time and usually it's the hardest. Data Lab Scotland, do we have British fellows, English, not Scottish? Yes, one English? Okay, Data Lab Scotland, because I'm really proud of them. In 5 years in Scotland, they found 200 MSc students. Every year they hold a data summit like this and bring people from all over the world. What is their mission? They want to lead the world. I know this is a big ask, but why not aim high? Let's aim high and hit some milestones. Drive the change, fund, monitor and evaluate. Higher education is my game. I want to be a bit critical here. I don't know much about Palestine. أنا ابن البلد وخرجت من فلسطين وفخور بجامعة فلسطين. If we are not research-driven institute, we cannot do this, guys. If my lecturer in the university, his last published paper was in 1990, he cannot teach me how to do deep learning and data science. The academics and the institute, they have to put resources to allow our academic colleagues who are great to push the research agenda and inform the teaching practice and review and evaluate. I taught in the past 4 modules data science, from introduction all the way to advanced deep learning. I never assessed a student using exam. I never told the student, do this tag. I tell the student exactly like that CEO. Go find the data set, articulate the problem, make your assumption, get the prediction, give me the results, and show me the story. Give them the freedom to think. The new generation is better than us. You know, I saw a computer when I was 23. Those guys were born with that thought. They are ahead of us and we have to match the game. Finally, to wrap up, this one. Knowledge exchange is of paramount. مركز الإحصاء لحاله can't do it, higher education alone they can't do it, and so is the government. On the right side, these are some of the companies that I work with, but there is these innovation funds like Innovate UK, Data Lab, EPSRC. They are funding half and sometimes 70%. And by the way, the government gets their money back. Because when you get a successful project, they recruit people, you will pay tax. It's a win-win situation for everyone. I'm so sorry that this is my team, and I have to stop here, but you can see everything almost in my staff page. And thank you very much, and sincere apology.
Thank you, Dr. Elian. Thank you all, dear presenters. And as we live at the time highly facilitated by the technology, may I suggest that we follow up on discussion about the presentation using the means of technology. Because for the time, we have to liberate this stage now for the next session. And for the sake of time, we need to leave our colleagues also enough space for sharing their knowledge. So it means my suggestion is that we will address questions to the presenters using their emails and their social networks. But this was very rich. Honestly saying, this can fill in a seminar of a full day or two, and there are many issues, questions, we need to absorb it, go again through the presentations, and rapidly think about where we would like to go with the data science to bring the values to the society. Thank you all for the attention. Thank you all for contributing to this session. And thanks to the organizers for allowing us to do this.
شكرا جزيلا للدكتور يوراي ريتشان مدير شعبة الإحصاء في لجنة الأمم المتحدة الاقتصادية والاجتماعية لغرب آسيا، وشكرا لجميع من شاركونا في هذه الجلسة.
نذكر السادة الحضور والسادة المشاهدين بوجود نموذج تسجيل للدورات التدريبية الخاصة بعلم البيانات. بالإمكان التسجيل عبر الاستقبال في الخارج أو عبر الموقع الإلكتروني الخاص Data Matters أو Data Science.
نتساءل ما الفرص المتاحة التي يوفرها علم البيانات؟ وكيف السبيل إلى اتخاذ قرارات صحيحة؟ وماذا عن استخدام علم البيانات والبيانات الضخمة في الإحصاءات الرسمية؟
في الجلسة الختامية السلام نترك المجال لمدير الجلسة الدكتور سام بحور، وهو ريادي ورجل أعمال، لمناقشة هذه الأسئلة وتقديم الإجابات والتعرف على علم البيانات في سياقه العالمي.
Assalamu alaikum. If we can bring to the stage Sakhir Namari, there's Tom Smith, hello, and Fidat Towa.
Thank you. Is everybody still awake? I always say the real conference attendees are the ones that stay to the last session. So this should be the picture of the conference right now. I'm pleased to be able to chair the second session, which is about opportunities in data science. As someone who was one of the founders of the operations of Palta, when I relocated from the US, I can remember that the first questions that we had is, where is our data? And there was none. Fast forward 26 years later, and I visit the Palestinian Central Bureau of Statistics website almost every day. So we've come a long way, and today's panel will talk about other opportunities that data science will present. And it's not only about creating a career path, it's not only about having career satisfaction if you choose data science, but it's also about using data for making public good, for serving our community. And I think this is what the culmination of this conference will talk about. Our first speaker will be Mr. Sakhr Numari. He's from the Bank of Palestine. He's from the analytics department, the business analytics department at the bank. He's a graduate of the University of Edinburgh in the UK in business and accounting, and he began his career with IBM Business Consulting Services in London in the corporate performance management. He'll be speaking on better data, better decisions. Says somebody.
ما انت بتفهم الامير، انت بتحكي مع امير، انا هيك فكرت خلص.
مسموع؟ السلام عليكم جميعا. I think everybody's been talking English, so we'll carry on in English. I'll try and go into Arabic back and forth, just to be a little clearer. So I'm here to talk to you about how Bank of Palestine is using data analytics, to improve the bank's performance. And we're going to try and look at it as an example of how practically organizations or companies in Palestine can start the journey to hopefully be like all the examples that we've been seeing in the world, where we have deep learning and machine learning and AI, and how we can gradually develop Palestine to get to the level of everybody else in the world, or let's say the leading people in the world. So, the first question I think that you will stumble across in most organizations in Palestine, so we're trying to look at practically how locally we can start to go on that journey, is why analytics? You know, the dreams are beautiful that we saw earlier today, but I'm sure the first question you'll hear from most executives in Palestine is, why? Why should I invest $100,000, $200,000, $1 million to actually get to the dream that you're selling me, which actually you will never get? Well, it's a pretty simple answer, and it's data analytics is for a purpose. It's to provide better decisions and actionable insight to organizations. So what do we mean by that? It means providing information from the data to decision makers, whether it's executives or whether it's automated through machine learning and AI, to provide value to organizations. Value, what do we mean by value? It means it could be reduction of costs. In a bank, it could be that I'm managing my loans better so that my defaults are less, or it could be growth. So I'm targeting new opportunities in new markets, new customers, and offering them things that they actually want to buy or take from the bank or whatever organization it is. And that's the purpose. As we said earlier, much of the decision making, as you gradually go to a more mature stage of analytics, is many of the decisions could be automated. So I could be, and this is the vision and the aspiration that we have in Bank of Palestine. You could go into our app, apply for a loan, say what your income is, and this is what we were talking about earlier. Say what your income is, where you're working, provide some bits of information, and perhaps the application will give you your loan immediately and give you the approval, and then the money will be in your account. This is the aspiration that we have moved a long way with Bank of Palestine, and this is what we're hoping to achieve. So, the answer is, it's not analytics or data science or machine learning for that sake. It needs to have a purpose. And I think this has come across in most of the things that we've discussed earlier, which is, there's always a hypothesis, there's always a need, there's always a question I'm trying to answer that in the end leads to a better decision or better value for my organization. Now, this is even more important as the data sizes grow and grow and grow. So there's no way, even with all the processing power we have, we can analyze all the data that we have for all purposes. So it needs to be for a purpose. So just a few. Just a quick, promise to be a little bit practical, so a quick overview of how is it done? How is it done in an organization? So yes, I want to go and I want to start analytics. I want to start working with data. How do I do it? What's the process that goes on? And this could be at a huge amount of data level, or it could be a small project that we start for a distinct area. And often, this is the way to actually start. I want to take a very small area and start implementing this process, as well as what all the colleagues have been talking about, which I think has been very rich earlier. So the idea is I have sources, data coming from everywhere, all sorts of data. It could be structured data meaning it could be a big system that has data in a specific format that follows specific rules, or it could be unstructured data, like data coming from Facebook, data coming from YouTube, or even documents. So a lot of the time we talk about unstructured data as voice or pictures, but actually one of the biggest sources of unstructured data is various documents lying around in an organization. A Word document that somebody produced, an Excel file somewhere that's mashed up, a website somewhere that has some data in it, so that's kind of also a rich source. And it's bringing all that data into a data warehouse or a data lake. If you're incorporating lots of unstructured data, it's mainly called a data lake. And it could be locally on a machine that you have, it could be in the cloud, it could be with Paltel, as we talked about earlier. That's the location. And it's bringing all the data and trying to do some sort of data cleansing and integration of the data. So, for instance, in Bank of Palestine, we have many systems. One for cards, one for the core banking, one for the mobile application that you run, or our internet banking. So we bring in the data from various systems into one place where we do a lot of linking of the data so that it becomes much more valuable. And this can be done again on a big scale, or it could be done for a specific purpose so that it could be done very fast and very efficiently. And then that's where the magic needs to occur. So this is where all the stuff we've been talking about earlier comes in. It could be machine learning algorithms, it could be AI, it could be just basic analysis, reporting, and visualization of data. So I know that a lot of the advanced stuff sounds very sexy, but some of the day-to-day and important things like visualizing the data correctly for a manager or for a CEO is, at least in the year we're in, just as important as automating everything and getting a machine to do it. So I think it's always useful just to think about that. And then so if you want a summary of the questions or the kind of analysis that can be done about data, it mainly, I've summarized it in 4 questions, which is what actually happens, which is discovering the data, having a look at it, trying to understand what happened in history. Then it could be, why did it happen? So analyzing some of the relationships of the data, some variables maybe that are influencing what's changing with the data. What could happen, which is getting into the world of predictive analytics. So I have a portfolio of 100,000 loans. Which ones are going to default? I'm expecting that these 10,000 actually, they're not going to pay their debt. And then, what action should be taken? And then there we're getting into the area of prescriptive analytics, which AI gets heavily involved in, which is you should go and restructure this loan, or you should grant this loan. And it's done on a machine level, or it's done automatically by the computers that are done. And then, of course, you have to deliver this in an accessible manner. So there's no point in having a great analysis of loans or whatever it is, of sales in an organization. You have to deliver it to the right people, in the right place, in the right format, so that these decisions could be taken effectively and quickly. And again, it could be delivered to the right application. So, because we're looking at the theme of automation and the age of machine learning, it could be that the data is delivered then to the mobile application, so that when the consumer is clicking the button, the result is yes, grant a loan, no, I'm sorry, or can you provide some extra information, or someone will contact you. So that's the summary. Okay. So just, I won't go through all of these because we're going to provide the presentation material for you, but these are some of the main benefits that we're personally looking at in Bank of Palestine. Things like better and more accurate insights, more efficiency, because we need less people to study loans, for instance, or less people to prepare all the reports and get them out to the executives and get the decisions made, etc., etc. I won't bore you with all these details. The final thing to say is, it's a journey. And as I've discussed earlier, it's not that all of a sudden you can suddenly have everything based on machine learning. It's a journey that you go through. And you'll have different parts of your analysis or your analytics at different stages. So for instance, in Bank of Palestine, we've done a lot of work on using statistical models to predict defaults. It's a part of the regulatory requirements, but we've done a lot of statistical analysis to say which loans do we predict are likely to default, otherwise not, in other words, not to pay their dues. But in some areas, like the financial statements, it's a case of we've worked on efficiency to get the financial statements done the next day before we close the next day after we close the month end, so that the CEO and our chairman and then the investors can see immediately the results and not have to wait a long time before seeing them. So it's a journey, and it's a journey from the typical situation where unfortunately a lot of organizations are in Palestine, where it's a lot of spreadsheets lying around, lots of manual work that needs to be done to prepare the end of month or to prepare whatever report that's needed, and then going through to having a consolidated, let's say, source of the truth where you can have self-service and access to the information as you need it, and then you start to integrate all this data into your forward planning processes, eventually going into the area where you can involve machine learning and other things like that to automate more and more. Thank you very much.
This is important. I think that the message on the last slide was key, that it's a journey. Too many times our students are bringing their certificates as if they've reached knowledge, and they're not seeing the journey of knowledge. So I appreciate the slide which shows the journey step by step. The second speaker on the panel will be Tom Smith. Tom is from the Data Science Campus in the UK, National Statistics. Dr. Smith is the Managing Director at the Data Science Campus, joining the Office for National Statistics in the UK in 2017. Dr. Smith has a PhD in computational neuroscience. When I read that, I had a problem because my daughter's studying neuroscience and I thought I knew what it was, but this is computational neuroscience. He has an MS in knowledge-based systems from Sussex in 1997 and an MA in theoretical physics from Cambridge in 1994. Dr. Smith will be talking about data science and big data for official statistics and public good, which is very relevant to our state building project. Dr. Smith.
Thank you very much, Sam. Can you hear me okay? Excellent, fantastic. Okay, and It's my great pleasure and privilege to be here, so salam alaikum. And thank you very much for the Palestinian Central Bureau of Statistics for inviting me. So I lead in the UK the Office for National Statistics Data Science Campus. So the Office for National Statistics is the UK's equivalent of PCBS. So you can see why this conference is highly relevant and interesting to us. And one of the things that struck me this morning was how many of the challenges we face are the same. We are trying to understand the world, the economy, the society, through data sources, that are becoming thicker and faster. Lots of the challenges this morning were about the speed, the volume, the type of data, whether you're thinking structured or unstructured. There are so many sources. And as statisticians and as national statistics institutes, it's our challenge and our duty to respond to this. We have to be able to produce statistics and data and analysis that decision makers in government, from the Prime Minister onwards, rely on, so robust and timely and fast data, but also that businesses can rely on, and also that NGOs and charities and universities. So we create the infrastructure. Data is infrastructure, just like roads, just like highways, like telecoms, like the internet. Data is infrastructure. People talked about data being the new oil. I'm not sure I agree with that. I think data is the pipelines. It's more fundamental than oil. It can be reused. And so that's a big difference. So what I'm going to hopefully take you through is really draw the links from some of the talks and presentations earlier and make the link with what statistics agencies globally are trying to do through some of the work that we're working on in the UK. So I've talked about ONS, so the Office for National Statistics. We cover the similar territory that the Palestinian Bureau of Statistics does. We look at the economy through things like GDP. We look at people through things like the census. We look at the world, so things like the Sustainable Development Goals. So we're highly interested in all of those things. But we were set a big challenge. All of the things that you've heard today basically come back to this challenge to a stats agency and government. Are you equipped? Are you able? Are you capable to respond? And the challenge that we were set 2-3 years ago was, what have we got in terms of understanding new data sources and the skills and the capability to do data science, machine learning, AI, whatever you want to call it? What capability do we have? And so the challenge was to grow a new team. So the Data Science Campus launched coming up for 3 years ago. And we launched with this kind of perception. This is an old problem. It is not a new problem. This is big data 80 years ago. So this is 4 million tickets from the underground transport system in London in 1939, so before the Second World War. People trying to use data which was generated from administrative data, people paying for tickets, to understand how can we optimize services. How can we produce better, more responsive services for our users? And it's exactly the same. Bring it forward 80 years and we still have the same challenge. So this was the challenge that Professor Sir Charles Bean set to my team. He said, the longer I have to wait as a decision maker for your data, the less likely it's going to, the less useful it's going to be to me. And that's exactly the same challenge that we had 80 years back in terms of using tickets like this. So how do we use big data? How do we use data science? I'm going to give you some concrete examples, so hopefully these start making it a bit real and start thinking about the opportunities that Palestine statistics agencies, that NGOs, that groups across the country have in order to use big data. And the first is this one. It's about speed. Every statistic and every data piece of analysis that we produce is used by someone. The output is just a report or a piece of data. That in itself is useless. It is only when it changes decision making that it becomes important. So the faster we can get that information and robust information in front of people, the better. Let's take a concrete example. In 2008, there was a global recession in many countries of the world. Very large impact on the economy and GDP, certainly in the UK, the US, and many other countries. The result, the impact of this took 5 to 6 years to recover from. There was a big downturn in terms of impacts in companies, many went bust, people lost their jobs. This was huge. What could we have done with faster information about what was happening here? There's analysis done by the National Institute of Economic and Social Research in the UK, estimated that the value of knowing that the recession was hitting, so faster information, was £12 billion sterling. So at that time, something like 60 billion shekels. That was, at the time, more than 1 billion per week. If we could have got faster information in front of decision makers, that made a real difference. So it's not just anecdotal or theoretical or academic, this is real information and real impact. So we've had a programme since launch around what data sources can we use that give us a faster understanding of what's changing in the economy. And we've many data sources that we're using, but this is the second lesson from big data. Use every source you can. There's lots of useful stuff out there. So the first is from company data sets, so this is shared by other parts of government. So every business has to produce tax returns, many of them on a monthly basis. We now get that data and can produce a monthly estimate using it to say whether business income, costs and profit go up or down. That's fairly standard, many countries do this. We're also interested in goods. How is goods moving around the UK? And let's look at traffic. So we have 10,000 road sensors around the UK which read out on something like a 10 to 15 minute interval, which tell you how many vehicles are passing and how big they are. So you can talk about goods vehicles, and that tells you something about the flow of information and of goods around the UK. A third source, the UK, much of it is an island, so a lot of our stuff comes in by sea or goes out by sea. If we want to know how imports and exports are changing, let's look at how shipping is changing. So global shipping GPS data sets are updated every 3 seconds for every single ship in the world above a certain weight. And we now have access to that data to produce estimates of the tonnage of imports and exports coming in and out of the UK. What this gives us are 3 completely different data sources which can add to the official statistics. So if you're sitting there thinking, how do we improve the data that we have in the economy so that the Prime Minister and the Cabinet and all of the departments can make better and more informed decisions, those are examples where you can bring in data from totally different sources and give yourself an additional basket of indicators. So the interest in this is high. We now publish these on a monthly basis, and we're looking at whether we can go to a weekly basis for some of them. The newspapers, the media, the information use this data set in order to make decisions and predict and look at whether they are likely to feed through into the official statistics that come out later. So it's an early warning system. Let's look at a totally separate example. That was something about faster data, different data sources. What about data gaps? There are lots of things we're interested in understanding or measuring, but it's very difficult to create measures for, particularly if you're doing it through surveys or even administrative data. So we know the environment, and particularly at local level, has a great impact on air quality, pollution, on health, on well-being, on mental health. Lots of really big, important issues. But we have a gap in data. At local level, let's say in towns or in villages, we don't have very good information on this. We can go and survey, but it's very expensive. So we set out with a question of whether we could use images to produce an environmental map, a data set that you can use, that we can publish openly for anyone else in government, business, industry to reuse. And so we started with a question around, can we use Google Street View? So street level imagery produced by Google. Available in many countries, not all. Other data sets are available. And we sampled Google Street View every 10 metres around the entire road network of the UK. It's not that big. We heard earlier about 1 billion images a day. This is kind of small fry compared to that. But it's still quite a significant level of interest. And spent a lot of time looking at how you can classify those images. can you use them to identify trees, vegetation, urban, shrubbery, and so on? What is the local environment like in terms of greenery and green space? And can we use that to produce a map and an estimate of the local environment at very local levels? Short answer is yes. It takes a lot of work, it takes a lot of processing, there's a lot of interest in data science there. All of our methods are public and available, so everything we do is openly published and open source. That's one of the points of the National Stats Agency. You're there to support others' reuse. And from this, we've produced estimates of greenery for local areas right down. So those you can see on the screen there, that's a single street in one area. That's our estimate of the local environment in that street. And we can produce that for the whole of the UK. But imagery goes a lot further. So we're kind of interested in what about aerial photography? What about satellite imagery? What can you do with that? So if we're interested in green space, then we might have data on gardens and parks and so on around the area or around the country. There are lots of techniques we can use to then turn that again into an estimate of what local area, what proportion of the local area is greenery. And this is really useful stuff if you're interested not just in greenery for the sake of it. It has impact on prices of local land. It has impact on health and air quality. It has impact on all sorts of issues. So again, lots of interest here in terms of how you can reuse this data and these outputs. A big scale example. What are we growing? What are crops like across the UK? Every country faces this challenge. You can survey, you can go and ask people, you can look at what people are selling, or you can look at whether you can do this for satellite imagery. This is the whole of England, so it's a large part of the UK, and these are the types of crops that are grown in every single part of that. This data and this map goes down to very fine grain, very fine scale, and it's created purely from satellite imagery. So it can be updated every few days if you so desire. And that's a really critical example, because if you're interested in how agriculture is changing or what the potential is in certain areas, and you start thinking, okay, I've got things like land use, and I know things around the local environment from this sort of analysis, or I've been doing survey work, but then this can give us a really good estimate of what is being grown and when, and how that's changing. You can go finer grains, and you can look at change in a matter of days if you're really interested. So another piece of work we've heard about Sustainable Development Goals this morning. They drive work not just in Palestine, clearly, but globally. The UK is very interested in producing the SDGs for ourselves, but also in supporting other countries and develop fine-grained measures and then using those for making decisions and targeting policy and resources. One of the pieces of work you can look at is how is water availability changing using satellite imagery that maybe has a resolution of 30, 40, 50 centimetres, so this sort of size. And if that's updated regularly, for example daily, then you can have a very clear view on what is changing in local areas. I'm going to finish with a completely different example. It takes us away from data science and more towards collaboration. And I think we're in an era, this century, where government knows less than business. And that's new. In the past, government held the cards, held the information. But now you have a case where many, many business organisations hold really important data. And you have a question that how do you leverage that for social good, for public good, for impact, without revealing sensitive data? One of the examples here is data that's held by banks, and we just heard a fascinating example of how Palestine Bank is looking at using this data in different ways. How could we use that as a statistics agency? So I've, for the last year and a half, been developing a project in a collaboration with one of the global banks based in the UK, where last month the team from group from my team spent a week with this bank seconded into their establishment, running analysis on their microdata. And what that can give you is a real-time look at what people are spending. So retail sales, sales by sector, what kind of industry sectors are growing in which areas and how. And that is just fascinating. So again, this gives you a totally different window from what we're used to as stats agencies. So I think this one, I kind of want to finish one in terms of the examples. Think about who else holds data that we can collaborate with, and how can we leverage that? How can we make partnerships with those groups in order to produce better statistics that explain what's going on in the country and at local level? So, final thing, just to sort of wrap up and so on, all of this takes skills. It was great to see the number of students and so on in the audience, also colleagues from statistics officers. This takes a lot of skill to do. And I think the message that I'd like to leave you with is confidence that stats agencies, statistics agencies across the world can tackle this. We can build and grow these skills across our teams. Data Science Campus in the UK is one example. There are many others. There is lots of support around. And many of the ways we have built our skills, I'm very keen on seeing how they might translate, sharing those examples with you, whether they're the sorts of things you can run here. And just to give you a quick rundown, we run apprentices to bring people in from school, so even before they have degrees. And they spend 3 or 4 years doing a vocational degree working on real stats challenges. So that's one area. Masters and PhD programs, of course. But the other one is around mentoring. So we run a government program across the entire UK government where people, analysts from any area, bid in and basically bid for 3 months of support, mentoring, coming in and working on a project for 1 day a week, which is mentored by people in my team, but also other teams in government. So it's a fantastic way of building capability and building the communities of people, because in this area you will have lots of expertise and lots of experts, but you may not know that yet. So it's a great way of bringing out that community. So lots of things we've done to develop skills, including playing with robots. So we talked about computational neuroscience at the beginning. The slightly easier way of describing that was my PhD was spent making robots play football before really we knew what the potential for neural networks back in the 90s, but we've come a long way since then. But a huge amount of things there, and really you can take this right back into schools. Encourage your students and pupils to take up STEM, so science, technology, engineering, maths. Encourage people to look at this as a career, think about how they can work on this for public good. So I'm kind of going to leave it there, and just all the links and so on available up from this talk, and I think as earlier, I'm very happy to have this published up on the website, or I'll make it available from my Twitter feed. All of our code is open. Everything we do, you can reuse. It's all on GitHub, which may mean stuff for some of you. All of our methods and so on, and wherever we can, we publish the data that comes out of the output. So I'm kind of finished there, but I think maybe just to go back to my first point, this is an exciting time. There has never been a better time to work in data. All of the stuff we've heard today shows how exciting, how many examples you can have, and all of the speakers have given great examples of that. That translates across to statistics and statistics agencies. So the challenge for all of us in national stats agencies is to make best use of data. And so I think we need to learn from each other, we need to collaborate, but we can also make a huge step change in the level of information that we provide to decision makers. So I'll leave it there, happy for questions, or I'm around later in the exhibition. Thank you very much. Shukran.
Thank you. Thank you, Dr. Smith. A very, very fascinating portrayal of what can be done to serve actual issues in our different sectors. The agricultural example is very live in Palestine today. We're in our olive harvesting season, and I heard that the Ministry of Agriculture was telling people not to pick their olives until after the 15th. And the number that comes up is if you pick your olives too early, you can lose 40% of your yield. So I think there's a huge opportunity for Palestinians to be able to use data to have an accurate picking season as well. Our last speaker is a homegrown data expert. Toam, a Director of Living Standards Department at the Palestinian Central Bureau of Statistics. She has been working in the Statistics Bureau since 1999 and is a graduate from Birzeit University.
يسعد مساكم. شكرا لانتظاركم. رح احاول اختصر قدر الامكان، رح احكي بالعربيه just for sake of change. احسن. رح نحكي عن تجربه فلسطين في خرائط الفقر، والتجربه هاي تعد من ضمن اطار الاستخدام الامثل للبيانات. تجربة خرائط الفقر في فلسطين انعملت لتحقيق الهدف منها واني اوصل لمستويات تفصيلية في نشر نسب الفقر. بالعادة نسب الفقر تنشر على مستوى ما يسمح به النشر من خلال مسح بالعينة، واقصى مستوى للنشر كان يتم عليه من خلال المسح هو المنطقة ضفة غربية وقطاع غزة، وافضل الحالات كانت اني اقدر انشر على مستوى المحافظة، هي شمالي وهي شمالي. فأقصى النشر لمستويات النشر كانت عندي المنطقة ضفة غربية وقطاع غزة. في أحسن الأحوال كنت إني أنشر على مستوى المحافظة، هذا لما كان حجم العينة يسمح. باستخدام خرائط الفقر قدرنا نوصل للتجمعات الفلسطينية على مستوى التجمعات في الضفة الغربية وقطاع غزة. يعني هون عندنا المثال عن محافظة الخليل، وهو تجمع من ضمن محافظة الخليل من خلال برنامج خرائط الفقر قدرنا احنا نوصل له. معلش رح أكبس. منهجية خرائط الفقر هي اعتمدت المنهجية على بيانات التعداد العام للسكان والمساكن تم تنفيذه في عام 2017، ومسح انفاق واستهلاك الأسرة اللي نفذ في نفس العام. اللي أخذته من التعداد إنه التعداد بيشمل كافة السكان في فلسطين، وعندي كافة البيانات التفصيلية عن الأسر الفلسطينية. مسح انفاق واستهلاك الأسرة اللي نفذ في نفس العام هو شغال مسموع. غلبتكم معي. مسح انفاق واستهلاك الأسرة مكنني إني بجيب استهلاك الأسرة الفلسطينية، واستهلاك الأسرة الفلسطينية اللي بعطيني نسب الفقر هو المسح الوحيد اللي بيمكنني من جمع بيانات حول استهلاك الأسرة الفلسطينية، وبالتالي يؤخذ استهلاك الأسرة الفلسطينية كقيمة نقدية يقارن مع خط الفقر، وبناء عليه تحدد الأسرة إن كانت فقيرة أو غير فقيرة. وبالتالي مسح انفاق واستهلاك الأسرة هو المسح الوحيد اللي بيمكنني من إعطاء مؤشرات حول الفقر. مسح استهلاك الأسرة بيجمع عدة بيانات عن الأسر، بيانات ديموغرافية، بيانات صحية، بيانات اجتماعية، حالة اللجوء، الحالة الزواجية، وهي نفس المؤشرات بتفاصيلها ومطابقة لمؤشرات التعداد. التعداد بيجمع كافة البيانات عن الأفراد في فلسطين من حجم أسرة، من بطالة، من مؤشرات اجتماعية، ومن مؤشرات صحية. وبالتالي شو اللي صار؟ اللي صار إنه الأسر اللي دخلت معي في مسح وانفاق واستهلاك الأسرة اللي هي الدوائر الحمراء، اللي أنا قدرت أجيب استهلاكها الحقيقي، والدوائر الزرقاء هي الأسر الفلسطينية اللي دخلت جميع الأسر الفلسطينية اللي كانت في التعداد. وبالتالي من خلال المتغيرات والمؤشرات المتطابقة ما بين التعداد ومسح انفاق واستهلاك الأسرة تم بناء نموذج اقتصادي يحدد العوامل والمؤشرات اللي بتأثر على استهلاك الأسرة. ومن خلال تحديد العوامل ذات العلاقة والمؤثرة والمتطابقة ما بين المسح والتعداد، تم بناء نموذج بقدر لي استهلاك الأسرة الفلسطينية. وبالتالي من خلال هذا الربط وهذا النموذج تم تقدير الاستهلاك الشهري لكافة الأسر الفلسطينية. بيعني إني أنا بقدر أحدد وأصنف الأسر سواء فقيرة أو غير فقيرة بناء على هذا النموذج. عدة فحوصات أجريت على النموذج، ومن أهم الفحوصات كانت هي مدى التقارب في نسب الفقر اللي أخرج لي إياه النموذج. هاي السلايد عن نسب الفقر في المحافظات، وهي المربعات الزرقاء، وجميع نسب الفقر للمحافظات وقعت بين فترات حدود الثقة، وبالتالي هي النسب كانت منطقية جدا ومقاربة جدا من المؤشرات الرئيسية اللي بنيت على الاستهلاك الحقيقي. جميع التجمعات كانت نسب الخطأ لإلها دون 5%، وغالبيتها كان الكوفشنت وفاريانس كان دون 20%. هذه الفحوصات جودة البيانات. هاي بعض علاقة عن النتائج. تم ربط نسب الفقر بعدة مؤشرات من التعداد، ومنها العلاقة ما بين التعليم والفقر، واللي تم انه ظهرت من البيانات انه لما يكون التعليم ما فوق الثانوي بخفض من نسب الفقر سواء في الضفة او في قطاع. تم تحميل كافة هاي قواعد البيانات او اطلس الفقر على صفحة الجهاز، وموجودة ضمن ايكون اسمه خرائط الفقر. ندخل على الصفحة سواء 1 انديكيتور او 2 انديكيتور، وبحدد المؤشر اللي بدي اياه وبدخل. هذا كان المخرج الرئيسي. هاي نسب الفقر على كافة تجمعات فلسطين. اللون الأفتح أقل فقرا، اللون كلما صار أغلق بزيد الفقر. واضح إنه جنوب الخليل وقطاع غزة هم الأكثر فقرا على مستوى التجمعات في فلسطين. بمكنني ايضا قاعده البيان، يعني هون مثال على تجمع. لما اكبس على التجمع ما راح نحكي شو التجمع، بعطيني نسبه الفقر بس بكون لكم ظاهر اسم التجمع، بعطيني نسبه الفقر في التجمع، بعطيني عدد الافراد في التجمع، بعطيني نسبه الخطا لهذا التجمع. مجرد احط الكيرسر على التجمع بالخريطه. شو بتمكنني كمان البيانات؟ اني ادمج مؤشرين مع بعض. ما بدي فقط نسب الفقر، بدي نسب الفقر مع البطالة، فبختار مؤشر نسب الفقر، بختار مؤشر البطالة أو الخارج القوى العاملة أو الالتحاق بالتعليم أو اللي عندهم الاشتراك بالإنترنت. حوالي 45 مؤشر تم استخدامها من بيانات التعداد وتم ربطها مع الفقر. هذا مثال على ربط الفقر مع نسب البطالة، وطبعا المفتاح في الآخر ببين لي شو اللون. يعني بدمج مؤشرين مع بعض بحدد العلاقة وبعطيهم لون واحد. اللون الأحمر الفاقع بيمثل لي إنه بطالة عالية وفقر عالي، وهذا كان الحال في جنوب الضفة وفي قطاع غزة. بينما اللون البني اللي يلاحظ إنه في أريحة أو في طوباس فقر عالي ولكن بطالة منخفضة، يعني يعملون ولكن فقراء. العمل ما نجاهم من الوقوع ضمن حفرة الفقر أو دائرة الفقر. هذا من الأمثلة البسيطة على المؤشرات اللي بقدر أنا أدخل فيها وتحدد لي طبيعة العلاقة ما بين مؤشرات الفقر أو أي مؤشر آخر. فإذا أنا معني بمؤشر واحد بقدر أدرسه، سواء مؤشر الفقر أو كافة مؤشرات التعداد موجودة تحت بند ال1 انديكيتور. إذا معنيني أظهر علاقة بروح على ال2 انديكيتورز وبربطهم مع بعض. طبعا بمكنني إني أعمل خريطة، بمكنني إني أعمل بارز أعمدة، وبمكنني إني أعمل لستة تحليل البيانات. وشكرا لك.
As a user of this system, I'm more confident now that I see you present it live. Thank you very much. I've been asked to make some final remarks to close the festival, if I can do them there. Thank you again for the second panel. Dr. Ola opened this festival in Arabic. I have the pleasure of closing it, and I'll use English because I respect the Arabic language. I don't want to try. As we bring this first Data Science Festival to a close, I think we can all agree that a solid foundation has been laid upon which a new knowledge-based industry in Palestine has been born. Palestine today joined many countries around the world in celebrating World Statistics Day. We do not shy away from noting that this is an additional step to put Palestine on the world stage at a time when the global powers to be are refusing to accept the will of the majority of countries around the globe which have already recognized the state of Palestine. We Palestinians entered a peace process over 2 decades ago, excited to leapfrog our development process, only to learn the hard way that Israel had no intention whatsoever of removing its boot of occupation from our collective neck. This did not deter our path to freedom and independence. We forged on. Every military checkpoint became an opportunity for us to visit our rural villages, which now became our pathways to move from point A to point B. Every section of the separation wall offered an opportunity for us to mobilize and expose this military occupation for what it is, a land grab. And as every Israeli action attempts to suffocate our economy in Gaza, in Jerusalem, across the West Bank, here we are, as creative as ever, forging a new industry forward, a knowledge-based industry that will employ, empower, and serve not only our steadfastness, but our state-building process. Today's festival is a prime example of a lesson learned. We can't do it ourselves. The importance of partnerships and exchanging experiences is a must for Palestine to develop and a must for the world to benefit from our Palestinian experience. Knowledge is a two-way street, and this festival has paved this new road forward. This festival did not drop out of the open blue sky. It comes in alignment with our national strategy, our national policy agenda, and directions of the Palestinian government. This is key because it is our inalienable right to plan our future and lead our own development. From the chambers of Washington, D.C., to the fancy conference halls in Bahrain, no bullying effort can hijack our right to lead our own development, because we will not let them do so. As our government agencies lead, our other sectors are engaged, working hand in hand. Ministries, academic institutions, research centers, civil society, the private sector, and all those interested in the field of data science are joined to bring today's festival to life in all aspects of our society. In a world drowning in information overload, we are keen to learn, apply, and contribute to the discipline of data science to the best of our abilities. But our struggle and our culture add an element to our efforts that we cannot ignore: our values. Only with our values firmly planted can we imagine everything from data-driven politics to data-driven development. We do not seek the data that occupation and dispossession have imposed upon us. Instead, we seek data to serve as the scaffolding to rid ourselves of this treacherous reality and put us on track to a free and independent state. Our national statistical system is one of the products of the many sectors that emerged out of the Oslo II peace accords. In particular, Article number 34, which was titled Statistics, addressed this issue. Like so many other outcomes of Oslo, we Palestinians built from the crumbs that were provided by the Israeli side in order to build our future. We do not throw out the baby with the bathwater. We do not throw out the baby with the bathwater because we cherish the baby, our struggle, and our emerging state. And we will sacrifice all that is needed until we are free, not because we are special, but because we are normal human beings. For all this to come together, human resources, qualified human resources, are core to our progress. We do not seek human robots that merely go through the motions of work. We aim for a labor force that thinks, analyzes, is data-driven, and value-grounded. This is the importance of today. We walk away not only with grand speeches and insightful panels, we walk away with a comprehensive plan forward. We hold this Data Matters Festival knowing very well that not all of our people are in a festive mood. Think Gaza, think refugees, in and out of Palestine. But we celebrate anyway. We launched a Think Data Science program, knowing very well that our data is skewed by 51 years of military occupation and 71 years of dispossession. But we seek data anyway. We aim to bring data science to our executives and leaders, knowing very well that many of our executives are prohibited from the freedom of movement and many of our leaders are imprisoned in Israeli jails. But we will upgrade the capacities that we can anyway. We are reaching our students in the Data Science for Schools, Schools Without Walls program, knowing very well that there are real walls, real fences, real settlements that are separating our students from their schools, but we will teach our young anyway. Lastly, we launched the Data Science Society of Palestine today, knowing very well that we have a destination, Palestine. And that requires us to organize, educate, and mobilize in assembly. No matter the odds, we will do all of this anyway. With all of that in mind, I wish you all safe travels home. We look forward to the coming year of work and are already excited to be able to present the progress that we make in the next Data Matters Festival. Thank you for all coming.
شكرا جزيلا للدكتور سام محور الريادي في مجال الأعمال ورجل الأعمال، ولكل السادة والسيدة الذين شاركوا معنا في الجلسة الختامية.
نوه للسادة الحضور أن جميع المواد التي تم عرضها في هذه الاحتفالية موجودة على الموقع الإلكتروني الخاص بالجهاز المركزي للإحصاء الفلسطيني. إذا بعد تلاوة البيان الختامي في اللغة الإنجليزية والتي تلاها السيد سام بحور، نقول أنه في هذا اليوم أطلقت مبادرة علم البيانات من خلال شراكات بين قطاعات مختلفة. تضافرت الجهود لجسر الفجوات وتعزيز الشراكات والفرص الكبيرة التي يتيحها الاستثمار في البيانات، كما استعرضت الجلسات أمثلة من الواقع بسياقه المحلي والعالمي حول مجموعة
بالإضافة إلى خريجي الجامعات والمعاهد وخاصة برنامج ماجستير علم البيانات في الجامعة العربية الأمريكية، وأولئك ممن لم يتسنى لهم فرصة العمل في السوق الفلسطينية حتى اليوم.
لا يسعنا إلا أن نشكر دولة رئيس الوزراء لمشاركته في إطلاق هذه الاحتفالية، وطبعا الجهاز المركزي الإحصاء الفلسطيني والشركاء سواء الجامعة العربية الأمريكية أو الشركاء الآخرين، وأيضا شكر لكل من قدموا الأوراق البحثية في هذا المهرجان، وبطبيعة الحال الشكر للحضور الكرام.
شكرا لكم.